And before I introduce our next speaker, I would like to tell that Susanne Kaiser is an independent tech consultant from Hamburg, Germany. Susanne is supporting organizations with building socio-technical system. Could you please help me with a really nice warm to Susanne Kaiser? Stage is yours.
Thank you so much. Thanks so much for the introduction. Thank you so much for attending this talk, despite the heat. So I'm from the north, so I'm not used to this temperature. So most initiatives that try to change or to optimize a system are usually directed at improving parts taken separately. So they tend to focus on local optimization of the separate parts of a system. But from a system thinking lens, local optimization of separate parts of the system will not improve the performance of the whole. Dr. Russell Eckhoff, one of the pioneers of the system thinking movement, stated that a system is more than the sum of its parts. It's a product of their interactions. The way parts fit together, that determines the performance of a system, not on how they perform taken separately. He also claimed if the systemic nature of a system or an organization is ignored, their efforts of improving or changing that system are doomed to failure. So when building systems in general, we are usually facing the challenges of building the right thing and building the thing right. Building the right thing addresses effectiveness and addresses questions such as, how aligned is our solution to our business and user needs? Do we create value for our customers? Have we understood the problem, and do we share a common understanding? Building the thing right, on the other hand, addresses efficiency, for example, efficiency of our software engineering practices. And it's not only crucial to generate value, but also being able to deliver that value to our customers. And how fast can we deliver changes, and how fast and easy can we make a change effective and adapt to new circumstances? And the one does not go without the other, but as Dr. Russell Eckhoff pointed out, doing the wrong thing right is not nearly as good as doing the right thing wrong. So to have the performance of the whole and considering effectiveness and efficiency and to build the right thing right, we need a holistic perspective to build adaptive system. And one approach that I would like to share with you today is combining the perspectives of business strategy with Wardley Mapping, software design and software architecture with domain-driven design, and team organization with team topologies in order to build, evolve, adaptive socio-technical systems that are optimized for fast flow of change. And this within 40 minutes. I'm sorry. So let's put these three perspectives together by evolving a legacy system. And we are using a fictitious example of an online school based on a legacy system and built, run, and supported by functional silo teams. And to start the evolution of our legacy system, we are going to start with a team first, and we are going to analyze their current situation in regards to the team cognitive load and their encountered delivery bottlenecks. So due to handover, the functional silo teams reported a high amount of communication and coordination effort between teams when implementing and releasing changes. Dealing with a big ball of mud with a messy model and fuzzy boundaries leads to high team cognitive load and created tight change coupling. It takes a high amount of effort to understand a piece of code. And the teams reported that there exist no clear ownership boundaries, so the teams were facing delivery bottlenecks impeding the software delivery performance. And due to on-premise infrastructure, the operational activities consist of configuration, backup and recovery mechanisms, maintenance, including upgrades and security updates, monitoring and scaling, and so on. So the infrastructure teams were facing high operational efforts. But as a reminder from system thinking, if we planned to optimize only local parts, if we do local optimization of separate parts of the system, that will not improve the performance of the whole. To improve the performance of the whole, we need to tackle the situation from a broader perspective and also understand the environment an organization is operating and competing in. And this brings us to a Wardley map representing the context-specific and landscape of an organization. A Wardley map is part of Wardley Mapping. So who of you have heard about Wardley Mapping before? Yeah, a few hands, roughly about 10 hands. So Wardley Mapping is a strategic framework invented by Simon Wardley, and it helps to design and evolve effective business strategies that are based on situational awareness and movement, following a strategy cycle. And this strategy cycle is composed of 5 sections. And this strategy cycle represents change and how we need to react to that change according to Simon Wardley. And it starts with a purpose, the why of our business. Why are we doing what we are doing? In consideration of our online school, their purpose is providing high-quality education for junior students everywhere and help teachers to engage with their students online. The next section of the strategy cycle is the landscape. And that is the landscape an organization is operating and competing in, visualized with a Wardley map. So let's create a Wardley map of our online school. So a Wardley map is composed of a y-axis and an x-axis. And the y-axis is representing the value chain. And to derive a value chain, we start first with identifying the users. And the users could be your customers, it could be your shareholders, your business partners, internal users, and so on. In our case, we are focusing on the teachers and the students of our online school. The next step is identifying the user needs. These are the problems that the users would like to get solved, and they are the subject area for which we build a product. In our case, the teachers would like to create course content, planning a class, helping students, evaluating the students' learning progress. The students would like to study the courses, requesting and receiving help from the teachers, and receiving evaluation feedback. And both need to sign up and sign in as well. The next step is to identify components fulfilling the user needs either directly or facilitating other components in the value chain, and determining the dependencies and the position in the value chain. So at the top, we have those components that are most visible to your users, where users are touching your system, and at the bottom, it gets less and less visible to the user. And the visibility and the value to the user, they are closely correlated. So the more visible a component is, the more value it provides to the users. And so in our case, to go back, and so in our case, the teachers and the students, they are interacting directly with an online school component, and it's located at the top of the value chain. And at this stage, we are dealing with a big ball of mud with a messy model and fuzzy boundaries as one single component that we are then going to decompose later when we come to the second perspective of domain-driven design. And this online school component depends on infrastructure components such as search engine, data storage, message broker, SMTP server, and compute platform running on top of a virtual machine component. And they are less visible to the users, so they're placed further down the value chain. The next step is to determine these components of your value chain and plot them along an evolution axis going from left to right. So at the left, we have Genesis with brand new things, then custom built, then product and rental, such as off-the-shelf products or open source software solutions, and then commodity and utility on the right. So, and the next step is to determine the stage of evolution per component. And to determine it, let's look at some climatic patterns that are impacting our landscape itself. And that's where we come to the next section of Wardley Mapping, the climate. The climate are describing climatic patterns. Simon Wardley compiled a list of roughly 20 to 30 climatic patterns, and they describe external forces that are impacting the landscape over which you have no control. However, understanding this climatic pattern is important when anticipating change, according to Simon Wardley. Understanding these climatic patterns gives us an idea where the landscape might change in the future. So, and one of the climatic pattern is that this landscape is never static, but very dynamic. So everything evolves from left to right through the forces of demand and supply competition. And for example, if you look at cloud-hosted services, decades ago they were non-existent, and they evolved through Genesis, custom build, became product and rental, and now commodity and utility. And why the components evolve, their characteristic changes through the evolution stages. So the characteristics of Genesis that we are dealing with components that are constantly changing, they are unpredictable, it's a poorly understood chaotic domain. And while the component evolves through the evolution stages, it becomes more stable and more mature, where we're dealing with a mature, known, wide and stabilizing, commonly understood domain. And we can use these characteristics to determine the stage of evolution for every component. So coming back to our example, our online school component is a volatile, changing frequently component that is providing competitive advantage. So that goes into the custom build, or can go into the custom build evolution stage. And the more mature, stable infrastructure components, they can go more into the product and rental or commodity and utility evolution stage. And we can apply or use different methods per evolution stage. And there we come to the next section of the strategy cycle, the doctrine. And the doctrine describes universal principles that every industry can apply regardless of their context. And the universal principles help to organization to enable them to respond to changes. They enable organization to respond, to gracefully absorb changes. And one of this doctrinal principle is using appropriate methods per evolution stage. That means that we should, for components, we should build components in Genesis and custom build in-house, using preferably agile methods. We should use or buy off-the-shelf products or use open source software for components in product and rental with preferably lean methods. Or we should outsource components in commodity to utility suppliers or using preferably Six Sigma methods. So coming back to our online school, we are going to, we have developed our online school components in-house. And we are currently at the current state using open source solution for our infrastructure components such as data storage and search engine and so on. And the virtual machine component currently is provided, for example, by a service hosted provider as an off-the-shelf product. And we are going to use the Wardley map of the current state of our online school for future discussions about how to evolve or indicate where to involve our online school. Before we do this, we also need to consider the team perspective. And to optimize for flow of changes from a team perspective, that we need to avoid functional silo teams with handover. Instead, we need to aim for cross-functional autonomous teams that are designing, developing, testing, deploying, and operating the systems they are responsible for. We need to avoid handover so that work is never handed off to another team. And we should aim for small, long-lived teams as the norm. And the teams they should own the system or subsystem they are responsible for, so they should have end-to-end responsibility. And we need to reduce the team's cognitive load, because if the team cognitive load is largely exceeded, it then leads to delivery bottlenecks and also leading to quality issues and delays. And while the communication within a team is highly desired, we need to restrict a high ongoing communication and coordination efforts between the teams to enable fast flow. And that's where the next perspective comes in, team topologies. Who of you have read the book of Team Topologies by Matthew Skelton and Manuel Paich? Okay, a few hands. So I'll give a brief overview. So Team Topologies provides well-defined team types and well-defined interaction mode to enable fast flow of changes. And we have the autonomous cross-functional stream-aligned teams that are aligned to a continuous stream of work and that are focusing on a fast flow of changes. In order to be able to focus on a fast flow of change, they need the support of other team types. For example, the platform team that are usually responsible for platforms that usually abstracts away infrastructure, networking, or cross-cutting capabilities. And they provide a platform as a service to the stream-aligned teams and other team types that then the stream-aligned teams can easily consume the platform they are responsible for. Another team type are the enabling teams, and they also support the these stream-aligned teams to help them to acquire missing capabilities. And then the complicated subsystem team as an optional team type that is responsible for particularly complicated subsystem, for example, face recognition, video codecs, and so on, and that requires very specialized knowledge. And all team types are having the goal to increase the autonomy of the stream-aligned teams and reduce their team cognitive load so that at the end it enables the organization for a fast flow of change. But arranging these teams in this team type is not enough to become effective. How the teams are interacting with each other is also very crucial for organizational effectiveness. So with collaboration, teams are working very closely together, aiming for a common goal. And it's suitable for rapid discovery and innovation, for example, when discovering new technologies. X as a service works well when, for example, when a team needs a code library or a component or an API or platform that can be effectively provided by another team as a service. And it suits well, or it fits where predictable delivery is needed. The last interaction mode is facilitating, and so when one team could benefit from active help of another team, and this interaction mode is very typical for enabling teams. And so this combination of this well-defined team types and this well-defined interaction modes, they enable or they promote organizational effectiveness. And while we are applying team topologies, we automatically apply also doctrinal principles of Wardley Mapping. So let's now start for architecting our online school for flow. And the first step that we can do is finding suitable streams of changes. To optimize for a fast flow of change, we need to know where the most important changes in our system occur, the streams of changes. And the stream of changes can change, the type of streams can change from organization to organization. There could be role, task, activity, customer segment, related oriented stream types. In our case, we are going to focus on the activity-oriented stream types because the user needs of our Wardley map are representing good candidates for activity-oriented stream types. So creating course content, planning a class, and helping students and so on, they reflect good activity-oriented streams of changes. The next step we can do for architecting for flow is understanding the problem that we would like to solve and understanding the problem domain and also partitioning it into smaller parts, the subdomains. And the teachers and so the users and the user needs of a Wardley map on the top of our Wardley map, they are also constituting the problem domain in regards to our to domain-driven design. And that's where we come to the next perspective. So who of you have read the book from Eric Evans, Domain-Driven Design? Keep your hands up. Who has read it to the end? Oh yeah, a few hands going down. So I needed 4 times to read it to the end. So it's really challenging sometimes, to be honest, but it's so wise. So domain-driven design is about designing software based on domain models, and domain models are reflecting the domain logic and the business rule for a specific area of a system. And the core statement of domain-driven design is to create a better software, we have to align its software design to the business domain, to the business needs, and to the business strategies. And then also, while we are applying domain-driven design, it also helps us to apply, to apply doctrinal principles of Wardley mapping as well. So let's start with domain-driven design and also using now the Wardley mapping as a foundation and then edit a new layer that is not part of Wardley mapping. And domain-driven design comes with patterns and practices of strategic and tactical design. In the problem space of strategic design, we are analyzing the problem domain and distilling the problem domain into smaller parts, the subdomains. But not all subdomains are equal to the business. Some are more valuable to the business than others. So we have different types of subdomains, core, supporting, and generic. And the core domain, that is the essential part of our business domain, providing competitive advantage. That is the essential part that we need to strategically invest in most. And it tends to be quite complex, and it's also tends to change very frequently. And that is the part of our system that we need to build in-house. So it needs to go then either in Genesis or custom-built evolution stage. The supporting subdomain supports the core domain. I come with an example later on. It does not provide competitive advantage. It's usually quite simple, and it does not change that often then compared to the core domain. And if possible, we should prefer to buy or use off-the-shelf products or using open source software that goes then in product and rental. And if this is not possible, if we need a specialized level, then we need to custom build it. But we should not heavily invest in that part of the system because it does not provide any competitive advantage. And the third one is then the generic subdomain. It's not core to the business. It does not provide any competitive advantage. But without them, businesses would not work correctly. So many business systems have the generic subdomain. For example, authentication and payment. So they are generally complex, but already solved by someone else. And they tend to be very stable, not changing very often. So we should focus on either buying or using off-the-shelf products or open source software, or outsource to utility suppliers. So identifying or discovering the different types of the subdomains gives us an idea where to strategically invest in most, where to innovate on in the core domain that provides competitive advantage. So let's come back to the online school. And so the user needs of creating course content, planning a class, learning support, and studying courses, they fall into the resort of a core domain, providing competitive advantage, leading to a high level of differentiation. So they are they tend to be quite complex and change very frequently. And it's not widespread in any other business system because that's our differentiator. And so the strategic investment should be very high in this part. On the other hand, evaluating students in their learning progress is not core, but supports the teacher's experience and is necessary for the organization to succeed. It's less complex and changes less frequently. And so we should not invest heavily in that part of the system because it does not provide competitive advantage. In signing in and signing up belongs to generic subdomain. So many business systems have authentication and registration. So it's a widespread standard expected with a high level of ubiquity and a high level of stability. And so they are generally complex, but already solved by someone else. And we should not invest too much into this part of the system. So there's no need for innovation here. So we are now switching from the problem space to the solution space of strategic design. And that's where we are going to decompose our big ball of mud into modular components, the bounded contexts. And the bounded contexts, they define where a domain model lives in, where the domain model is applied. And they form a unit of mastery, purpose, and autonomy. And they can also provide different types of boundaries. And we are focusing today on so they would serve very well as ownership boundaries, and we are going to address this later when we come to the team constellation. And one core part of domain-driven design is the close collaboration between the domain experts and the development teams. And there are different techniques available to design bounded context and domain models, for example, with using event storming or domain storytelling, example mapping, user story mapping, and so on. So they are complementing each other. So in our example, coming back to our online school example, so we have designed the bounded context of content creation, course studies, class management, and learning support, and they fulfill the core domain-related user needs. And student evaluation and notification handling, these are the bounded contexts that belongs to the supporting domain and supporting subdomain, and identity and access. They belong to the generic subdomain and going then into product and rental. And for student evaluation and notification handling, we could also search for available products in the market, but the team decided at that point that we needed a higher level of specialization so that we are custom building a supporting subdomain, but with the focus on that it should not be, the strategic investment should not be too high. So, and the next step is then finding suitable team boundaries, and there we come back to, guess what, to the bounded contexts. And because bounded contexts, as I said earlier, define well-defined ownership boundaries, providing a unit of purpose, mastery, and autonomy. And the bounded context could be used as suitable team boundaries for stream-aligned teams. So the next aspect for architecting for flow is optimizing for team cognitive load. As I said earlier, if this is largely exceeding, then we are encountering delivery bottlenecks. So for optimizing team cognitive load, we need to limit the number, the type, and the complexities of the components that a single team is responsible for. And there I come back to bringing back then the characteristics of the evolution stages. So if we have bounded contexts or components in general that are more located on the left spectrum of our Wardley map, then we are dealing with a high level of uncertainties, and this requires then practices that are more focusing on exploration and discovery. So components on Genesis, they change far more frequently than components in commodity. In commodity, we can draw on best practices, providing a clear path to action. And each evolution stage can have its own different paths to action, for example, ranging from best practices, good, emerging, and novel practices. And the more unclear the path to action is for a component, the higher the team cognitive load might be. That means, as a heuristic in the end, that a single team can own more or larger components that are located on the right spectrum of our Wardley map towards commodity than located towards the left spectrum of our Wardley map. And also to optimize for team cognitive load, we need to create clear ownership boundaries. So that means that we have to assign one bounded context to one team only. If we're sharing bounded context, that might diffuse the ownership boundaries. But on the other side, one team can own several bounded contexts. And the last aspect for architecting for flow is identifying services that are needed to support a reliable flow of changes. So the streamlined teams, they need to rely on a platform team providing a platform as a service that can be easily consumed by the streamlined teams. And this platform can be a sinus viable platform that is just a platform that is just big enough to fulfill the user needs of their consumers and should not be bigger than needed. And it could start, the platform as a service could start with documentation, with standards, with best practices, and or templates, and can evolve later into self-service APIs and tools. So, from this previous consideration, this might be a possible team assignment. So, in organization, it should be composed of mainly streamlined teams. So in our case, the 4 core domain-related bounded contexts are split among 3 streamlined teams. And the supporting and the generic subdomain is going to be handled by another streamlined team. And the infrastructure component are then taken care by 1 or more platform teams. And there's one other aspect that I would like to bring in before we go into the implementation for flow, is to identifying potential efficiency gaps. If we are dealing with inefficiencies, so inefficiencies can also impede our fast flow of change. So we need to identify potential inefficiencies in our system. And for example, if we are using components in our organization that are less evolved than the components that are available in the market, we might encounter efficiency gaps. For example, if you are custom building components, and these components are more evolved in the market, for example, available as commodity, we are lagging behind and we are less efficient. And there's, to optimize for fast flow of change, we also need to consider that we need to close our efficiency gaps, for example, with a cloud migration strategy that I will briefly cover in the next slides. So now we have we didn't touch any code yet. We did not rearrange any teams yet. So far, we have only designed or architectured our system for flow. Now the question is how we evolve from left to the right. And we are doing this with a team-first approach by dynamic reteaming. There's a great book from Heidi Helfand about dynamic reteaming. And dynamic reteaming and the evolution of team topologies interaction modes, supporting and executing then a cloud migration strategy. So first, we want to close our efficiency gaps. And there we are focusing on our infrastructure components currently in product and rental evolution stage. And we would like to make them more efficient, moving to commodity by migrating to the cloud. So and since we are focusing on the infrastructure components, we are, as a team-first approach, form first our platform team composed of members from the previous back-end and infrastructure teams. And this new platform team is then starting, kicking off the cloud migration strategy. And this first platform team is working on the site with the possibility and the freedom to learn, explore, and discover and assess cloud migration strategies, and determining a migration plan and the new platform. And for example, they might decide to re-platform the on-premise infrastructure by modifying the underlying infrastructure while keeping the application architecture the same. So we can do this incrementally from component to component, and moving then the components from infrastructure, from on-premises product and rental evolution stage infrastructure components to cloud-hosted services, where we then have replaced the on-premise infrastructure component with cloud-hosted services, and also reducing the operational efforts that I was describing at the beginning, and moving the management of the infrastructure component now to the cloud provider. So as soon as the infrastructure has been moved to the cloud ecosystem, the remaining infrastructure team can then also merge into the existing platform team. And from there, they can split later on into several platform teams if this is necessary. So far, we have migrated our infrastructure components from our legacy system using cloud-hosted services and closing the efficiency gap. And the next step is to modernize our messy model, our big ball of mud, and eliminate their delivery bottlenecks. And we are going to do this by starting the next cloud migration strategy of refactoring. And this usually involves breaking our application apart into smaller components into the bounded context that we have previously designed. And we are going to kick off the refactoring journey by starting the next team, by forming the next team of the streamlined teams from members of the previous front-end and back-end teams. So they start the refactoring journey. And in the meantime, the remaining front-end and back-end team can merge, taking care of the remaining big ball of mud as long as it's still existing. And coming back to the streamlined teams kicking off the cloud migration journey, they are getting no support from the platform team. And this is where we are dealing then with the evolution of interaction modes between the team types. So at the beginning, the platform team and the streamlined team can closely collaborate and discover and assess cloud options that are relevant for this bounded context that the streamlined team is responsible. That could evolve later in limited collaboration and on-demand collaboration, and later evolve into X as a service, and where the platform team can provide best practices, standards, tools, APIs, and so on. From there, the next streamlined teams can build and form and refactor their bounded context. And it's getting then also support, again, from the other teams, from the previous platform team and the previous streamlined teams. For example, coaching them how to use what cloud options are available, how to use the new CI/CD pipeline in the serverless ecosystem when the streamlined teams decided to use serverless technologies. And the other streamlined teams can also facilitate the new streamlined teams with, for example, how to implement AWS functions in a hexagonal architecture, something like that. So, and from there, the next streamlined can can build and form and getting support again from the other team types so that we can refactor step by step the big ball of mud into separate bounded contexts. And then optimizing our system for flow that we have designed before. So we have now moved from our functional silo teams to well-defined team types and interaction modes of team topologies. And we were able now to restrict our high communication bandwidth between teams. We were able to decompose our monolithic big ball of mud with a messy model and no clear boundaries into well-defined boundaries and bounded contexts and domain models, providing a clear ownership boundaries. We could move our tightly change-coupled system into a loosely coupled system. We could optimize our team cognitive load and eliminate delivery bottlenecks, and also reducing the operational efforts by offloading management of the infrastructure component to the cloud services. So that at the end, the combination of the three perspectives of Wardley Mapping, domain-driven design, and team topologies help us to understand the environment an organization is operating and competing in. It helps us gaining domain knowledge and discovering the core providing competitive advantage. It helps us to know what components to build in-house, where to use or buy off-the-shelf products or open-source software, and where to outsource to utility suppliers. It helps us to decompose our problem domain into smaller parts, into modular components, the bounded context, and aligns our teams and evolve their interactions to the strategy, the system we build and strategy we plan. It helps us to identify potential efficiency gaps, eliminate bottlenecks, and increasing our software delivery performance. And we are able to respond to changes quickly and absorb changes gracefully, so that the combination of Wardley Mapping, domain-driven design, and team topologies provides a holistic tool set to build and evolve adaptive socio-technical systems that is optimized for fast flow of change with a focus on improving the performance of the whole. And with that, thank you for listening.
Hello. I think that we don't have so much time for question and answer, but maybe we can end up with one or two. Yeah. What is the best resource to learn Wardley Mapping?
Oh, I have a next slide about the resources. So this is Simon Wardley has written his book. It's an online. It's published under Creative Commons, so you don't have to pay. You can just download it. And there are a lot of great GitHub repos as well, sharing also a lot of resources, talks, documentations, trainings, and so on. I've put it in the resources slide that I want in my slides that I will then share with you later on.
Great. How can we balance between having long-lived teams and transitioning teams to the team setup needed in the next steps for the product evolution?
Yes, so usually the long-lived teams that are, so Simon Wardley, for example, comes with the different think aptitude and attitude that the teams itself is not only composed of skill sets, but also about like your mindset, like pioneers, settlers, and town planners. And he suggests that if you have a team that is responsible for components in a specific evolution stage, for example, in Genesis, there you are dealing with a very explorative, experimental mindset of pioneers, then the teams that are taking care of the product and rental evolution stage components are more in the settler, where you stabilize and maturing a product, and then also in the commodity evolution stage, where you're then more on maturing a product itself. So there you have then the town planner's mindset, and he suggests to have different mindsets that are then focusing on different evolution stages, so that when your product evolves from Genesis to custom build to product and rental evolution stage, that you can hand over this one to another team if you want to. But this is usually not happening within just a weekly evolution. It takes years before you can do this.
Awesome. Susanne, we have something for the craft organizers.
Yes.
Thank you, Susanne, for your wonderful talk at Craft.
Thank you so much.
Please give her a really nice applause.
Thank you.